So welcome to the tutorial on ion mobility using FluoroMatch IM. So this is for PFAS analysis with ion mobility, and the software covers a lot of steps including collision cross-section based identifications, visualizing 3D plots, which you can see in the next video tutorial, as well as homologous series automatic detection, so on and so forth. So in order to run this software, first you must download it from the innovativoomics.com website. So if you go to innovativoomics.com and then you go to software, you'll find the ion mobility tab under the FluoroMatch LC tab. Download it, you'll get a zip file, unzip it into some other folder. Now you have an unzipped folder, and first you need your input data. So your input data is going to be a feature table that is both peak-picked and deconvoluted using whatever your favorite ion mobility feature detection software is. Now, we support LC ion mobility, high-resolution mass spectrometry, so you'll need that 3D or 4D peak detection capabilities. In our case, we used Agilent's Mass Profiler, although the software is vendor neutral, and you should be able to use other vendors as well. Now, there are 5 columns that are necessary. The identifier column, which is going to contain unique numbers, and none of these numbers are going to be duplicates, and there's nothing other than numbers in any of these columns, really, not the retention time, drift time, collision cross-section, or mass to charge value. Now, these columns can be in any order, and they can have any name. So that's okay, but as long as your data starts in row 2. So your numeric data should start in row 2, so you should only have one row of headers, so you might have to move things around. If you don't have an identifier column with your software, you can obviously just add one like this and drag it down. Now, if you don't have collision cross-section values, they weren't calculated, or you don't have retention time, for example, that's okay. You'll be missing a lot of features of the software, but if you still wanted to try the software, you could put a 0.1 under both of these and create a dummy values. Now, you can also have other columns as well with other types of information, maybe abundance across all the different features aligned, so on and so forth. And this can be implemented into the visualization later on, so whatever things you might want to include in plots, you might want to have here as well. But these are the only 5 columns that are necessary. Once you have those columns and that table, save it as a CSV. So that's a .csv. Notice that, let's say you open up your file in Excel, the way you want to save it is go to Save As, CSV, delimited. Don't use any of these other CSV options. So now that you have your inputs, the next thing you want is to make sure you have libraries and repeating unit files. The library is going to contain CCS values for PFAS standards or experimental data. So we have about 200 standards that have CCS values compiled by David Weil from Agilent Technologies that we use as our default libraries. And you can see that at minimum you want in these files a name, a formula, a mass to charge, CCS values obviously for matching, and then some SMILE structure. Your name can also have any kind of identifiers or anything else you want with it. And those are the columns that the software is going to use when it matches. Now, if you don't have SMILEs or formula, etc. for certain compounds, you can always put an NA. And the software will still work. Now, the repeating units file is going to have all of the different repeating units that the software wants to look for. So CF2 is what we set to true, and what we recommend you just leave it as is. But if you have other repeating units, please add their formula, and their formula should be clean because the software reads it and interprets the mass from the formula. So it should be a very clean formula, no other characters other than the letters and the numbers. And then over here, you can name that repeating unit whatever you want, and the software is going to use it to characterize homologous series, and then put it as true. Now, for most users, you'll probably just use this library as is, and we'll continue to add to it, and you'll use this repeating unit file as is, and we'll continue to add to that as well. And you won't have to edit these at all. Now, in order to run the code, you're going to want to use the version of R that comes with the software because it has all packages pre-installed. The software is working well for this version of R. So go into R 4.2.1. You can see the directory in the manual over here if you need help, as well as information for installing R. So we're going to go into R bin x64 R GUI, and then it opens up. We're going to check to make sure that the libraries that it's using are the correct ones. So you go .libpaths, press enter, and in our case, it is using the local libraries. You'll know because it will have, the libraries will be within the FluoroMatch iMobility folder that you unzipped. If not, then you can follow the directions on the written tutorial. Better go on the website version. It's a shared doc, as that one's updated continuously. And you can see that you can change, you paste all of the libraries from wherever the libraries are held locally. You want to paste it to there from your software itself, which will be in the R 4.2.1 library folder, and delete everything in your local library and add these libraries there. Or you can change the paths that it's looking for libraries. But this is the ideal way to do it, is to move all those libraries to your local library that it's trying to grab it from. So read that carefully. So once you have R set up, as it is here, then you can open up the scripts. And for example, a text editor you could go to open up. I opened it up in RStudio, but you don't need RStudio. You can use EditPad, is free, the light version. Notepad, you can open up WordPad, so on and so forth. And you can open that up. Highlight the whole thing, copy it, and paste it. For some reason, my R crashes the first time when I do that, so I'm going to open it up again and paste it. So, very important is it will stop here, but check that you have no errors on the loading libraries. So, you should get, these warning messages are fine, but you should get that it all loaded all these required packages. And so you see here that it did. If you have an error and it wasn't able to load some of these packages, that means you have to follow the tutorial very carefully for moving your libraries into your local libraries as well, so it has access to those. Now, a GUI will show up. Sometimes it shows up behind things, so you have to minimize until you find it. So here's the GUI. And now you want to choose your input file. So here's the file you want to choose, which is your feature table. You want to choose your library, so that's the one that came with it, and the repeating units file we discussed. Now, all of these parameters for the CCS library should stay the same unless you're developing your own CCS library. All these parameters can stay the same, although these are tolerances, right? So if your mass accuracy is not so great, you might want to not have plus or minus 0.005 Daltons. Or if you have really good mass accuracy, usually I wouldn't put it below plus or minus 0.005 Daltons, but you can. Same thing for collision cross-section. We have plus or minus 1%. Agilent systems do go lower than that as well if they're well calibrated, so you might want to lower this as well, or raise it if you have some issues with your collision cross-section tolerance. Mass defects you can leave the same. These contain most of the PFAS species. They won't be removed, they'll just be flagged. So anything out of this mass defect will still be detected. And you always want your data to start at row 2 of your feature table, as we discussed. So the only columns, and we're going to click yes for retention time and drift time order flagging. That's saying in a homologous series, so let's say, my perfluorocarboxylic acids, I have one with 2 carbon fluorine units, 3 carbon fluorine units, 4 carbon fluorine units, etc. They should be going up in retention time as well, and up in drift time. And if they're not, they get flagged. Now, like I mentioned, the only thing you might want to change is, depending on your input feature table, these columns might be in different orders. So, in this case, my ID column is the first one, my retention time's the second, drift time's the third, as you can see here. So ID column is the first, retention time the second, drift time the third. So you might want to change these columns if appropriate to your file. Then all you do is click run. The software, as you'll see here, will start running. And if it runs well, then you should get an output in the same folder as your inputs that has _fin. And the software works quite quickly. So as you can see, here's the file generated.